Hello, everyone. Welcome back to Science Behind Evidence, Episode 3. Today, we'll be studying about bloodstain pattern analysis. Imagine a murder has taken place inside a bedroom. There are no eyewitnesses. The killer has wiped his fingerprints, cleaned the weapon, and even removed the CCTV DVR. Police have almost no evidence. But when forensic expert enters the room, looks only at the bloodstain on the wall and says the victim was standing right here. The attacker was taller than the victim. At least 4 blows were delivered. After the third blow, the victim collapsed. The body was later moved from here. Everyone, I repeat, everyone in the room was shocked because nobody witnessed the crime. So, how did the forensic expert know all this? Today's topic, bloodstain pattern analysis, will answer that question. Now, let's first understand the formation of a bloodstain. It is a complex event that is influenced by viscosity, surface tension, cohesive force, and gravity. The molecules of a blood drop are held together by cohesive force to maintain the shape of the blood drop. Surface tension, on the other hand, causes the liquids to minimize their surface. As a result, the formed blood drop is spherical in shape. Now, in the diagram, can you see these arrows? These black arrows and these white arrows. The black arrows shows the cohesive forces, and the white arrows you see are showing the surface tension. Now, in the above diagram, this is a blood drop on a tile, this is a blood drop on a cardboard, and this is a blood drop on a paper towel. Can you analyze the difference? The blood stain that lands on a porous or rough surface usually have more distortions around the edges of the stain than those that land on the smooth surface. This is the reason why the blood stain on the tile had smooth edges as compared to the ones on the cardboard and the paper towel. Now let's analyze the spatter stains. In this, we'll first understand the velocity of blood drops. The sizes of the blood stains are affected by the external forces that is directly applied on a blood source. When the external force is increased, the surface tension decreases, which eventually decreases the size of the blood drop, and when the energy of the external force is increased, that increases the velocity of the blood drop, which also decreases the size of the blood drop. Now, based on the traveling speed, we have 3 categories of blood stain. Number 1, low velocity impact, medium velocity impact, and high velocity impact. In low velocity impact, the speed of the blood stain is less than 1.5 meter per second, and the size of the stain is greater than 4 mm in diameter. Medium velocity impact is formed when blood source is subjected to force associated with beating or stabbing. It has a size 1 to 4 mm in diameter. High velocity impact is formed when force associated with shooting. It has a size less than 1 mm in diameter. Now, can you see the difference? It has less than 1 mm diameter size. It has greater than 4 mm diameter. Because the velocity, here the velocity is the lowest and the size is the highest. See, high velocity gives decreased size in the blood drop. It has the highest velocity and it has the smallest size. Now you understand this. Next is direction of a blood stain. The directionality analysis is applicable when the blood source is projected onto a surface at an angle between 0 degrees and 90 degrees. The resulting spatter is an elongated ellipse that is known as the parent stain. Let me draw it and show you. It is something like that. This is your parent stain. This is your spine and this is your satellite. The spine tells the directionality of the stain. Okay. Spine is a pointed edge on the stain that points away from the parent stain. Now let's understand the angle of impact. It is the angle at which a blood drop strikes the target surface. When the blood drop striking the surface is at 90 degrees, it creates a circular parent stain with its length and width approximately equal. Very important. When the drop striking at an angle between 0 degrees and 90 degrees, it creates an elongated stain. When the angle of impact keep on decreasing, the stain becomes more elongated. Its length exceeds the width. Let me draw it. This is your stain at 90 degrees. This is not circular, fully circular. The length and width are equal. When you decrease the angle of impact, this is how the stain looks. When I further decrease the angle of impact, then it would be something like this. The length increased and the width decreased. When I further decrease the angle of impact, the stain would be like this. The length further increased and the width decreased. When I again decrease the angle of impact, the stain would be like this. And this is your formula for angle of impact. Sin alpha equal to width upon length. This alpha is your angle of impact and alpha is equal to sine inverse width by length of the parent stain. Now moving forward, area of origin. Area of origin can be accomplished by either string or tangent method. In this string method, multiple stains, approximately 2 dozen stains are selected and strings are connected from the stain to the surface. Here, these are the strings that are connected from the blood stain to the surface. These are the strings. These are path of the strings. This is the area of origin where all these strings are meeting. There are certain tools for finding the area of origin, such as the laser trajectory pointer, in which you don't have to physically connect the string from blood stain to the surface. Next is the tangent method. In this, directionality of single stain is determined first. A line is back projected. This line, it is back projected through major axis of blood stain. In this also, approximately 2 dozen stains are selected for the calculation. here this is the height of area of origin, and this is the backward projected line. This is denoted by D, the distance of backward projected line, whereas this point is your area of convergence. It is the area containing the intersections generated by the lines drawn through the long axis of individual stains that indicates in 2 dimensions the location of blood source, not store. Okay, so the height, this height of area of origin is calculated by this formula, H equal to D tan alpha. This D is the distance of backward projected line, H is the height of area of origin, and alpha is your angle of impact, this angle. So that's all for today's video. In the next video, we'll study about the types of bloodstain patterns. Till then, remember, evidence doesn't lie. It only waits for someone who knows how to read it. I'll see you in the next episode of Science Behind Evidence.